Now the very last question. E. Find the distance each travels in that time. Now, since we are asked to find the distance, which is x, we have our a to be this, our t, and our u to be 0. So using this equation, we have our s 2.8 meters. Or using this other one, we also have our s to be 2.8 meters. Quite easily done. Okay, let's look at the second question for this course. The diagram below shows a wedge with a smooth surface and two masses connected by a light string over a smooth pulley. The strings run parallel to the wedge surface. Find the acceleration of the masses and, of course, the tension in the string. We are asked to take acceleration due to gravity as 10 meters per second squared. Now, this is the weight. Since this weight is greater than this block of mass 3 kg, it accelerates downwards by this component of 3 G-newtons, and of course this one accelerates upwards. Now, to find the acceleration and tension in the string, we need to analyze the resultant force, and in this downward direct, the resultant forces in this downward and upward directions, and then use equation of motions, precisely second law of motion, to find the acceleration and tension. Now, the resultant force, since this block moves downwards or accelerates downwards, the resultant force must be this force, this component of 3g minus this, and that is what we have here, and that equals 3a from second law. And at the same time, since this accelerates upward, the resultant or net force must be this minus this, which is what we have here, and that equals a from second law as well. Now, solving these two equations simultaneously and by using elimination method, we have 2g sine 30 degrees to be 4a, and that makes our acceleration to be 2.5 meters per second square, and that answers this part of the question. Now, to find the tension in the string, all we need to do is just to slot in our acceleration into any of the two equations. I prefer this very one, the second equation. So going by this second equation with our parameters a and j put appropriately into the equation, we have our t to be 7.5 newtons.